This is Maris. Sometimes we call it the monster just because it's so big and it's actually pretty complicated to assemble. The purpose of Maris is to study muscles, and in particular muscle atrophy in space. And now it's of course all tucked away and sleeping in its rack. But during the Futura mission, I had the chance of actually assemble it and do some calibration work on it. There's a few things that you can find everywhere on the space station. Velcro for one thing, or bungees, or grating, or seat racks. They're installed everywhere on all of our racks, and they allow us to attach things that are useful for us to live and work up here. For one thing, handrails. Handrails are everywhere, and we use them, of course, to hang on to, or a lot of times to put our feet under, so we have our hands free to work. There are different types of interface with the seat rack. This is actually my favorite one because it's really easy. You just have to press on this side, and it pops out and it engages. So to attach it, we push this back in, both sides, of course. And then we align it and engage it, and it's ready to go. So now I can, for example, slide my feet under, and they're nice and secure, and I can work with my hands. Or some people find it more comfortable to use foot restraints like this one. You attach it. It's really simple to the handle, and then again you can slide your feet in. Ideally, I would have a second one, and then I can work with my hands. Or there's many other things you can attach. On a handrail, for example, a bracket like this one. It attaches very easily and quickly. And for example, on a bracket, I can put a camera. And I can take a picture of it. In this corner of Note 2, I can show you some of the emergency equipment we have up here on the space station. This is an emergency locker. In the known Russian modules of the space station, typically there are 2 of them in each module. The Russian segment is organized a little bit differently. And if we open the locker, first we find an oxygen mask. We call them PBAs, portable breathing apparatus. And if I had to wear a mask, of course I would turn on the oxygen supply from the bottle and then squeeze in those 2 red tabs. If there was oxygen supply, those straps would inflate and rigidize, and it would be very quick and easy to don the mask. We would wear a PBA in case of fire, of course, in case of smoke. If the ammonia alarm went off, if we suspected presence of ammonia in the cabin. A supply from the bottle lasts for about 7 minutes. If we had to work on a PBA for a longer time, we could consider using a hose. So connecting it with this hose, which is pretty long, connecting it to the oxygen ports. There's a number of them throughout the station, and then we are free to move around because the hose is very long, and we are connected to a virtually infinite supply of oxygen. Another reason why we would wear a PBA, put on a PBA, is if we had to discharge a fire extinguisher. And that's because our fire extinguishers, at least in the known Russian modules, are based on CO2. So they basically discharge CO2, and the idea is that they will displace the oxygen and kill the fire. And you can discharge a fire extinguisher in the open cabin if the fire is in the open cabin. However, if it's behind a panel, you might need, or you certainly will need, an extension like this one, because you would have to discharge through a fire port like this one. And the idea is that each fire port allows you to discharge the CO2 into a fire partition, and theoretically the fire should be contained in this volume and not be spread beyond this one fire partition. Another piece of equipment that we would pay attention to during an emergency is this. It's an inter-module ventilation valve. If an alarm goes off on the space station, be it fire or depressurization or ammonia leak, in most cases the auto response of the vehicle, of the space station, will close all the IMV valves, or the intermodule ventilation valves throughout the station. But as crew member, of course, we need to verify that they're really closed. For example, let's say that we found a leak here in the JAM, in the Japanese laboratory. Of course, we would want to isolate the module, so we would close the hatch, but we would also have to make sure that the IMV is really closed. Otherwise, there would still be exchange, the Note 2 and the JAM would still be connected, not isolated, and we would still be feeding the leak in the JAM with the air from the rest of the space station, which of course we don't want. If you have ever wondered how crew members of the space station always know where they are above the Earth, well, it's not because we are also good at geography, at least I am not, but it's because we have World Map, which is a really cool software that runs on all of our station support computers, SSCs. We have about 20 of them spread throughout the space station. And it tells you just that, where you are. So you can see it has a map of the world, and the continuous pink line is the current orbit we are on, or the ground track of the current orbit we are on. And then the next two orbits are those two pink dotted lines. So here you can see, and then of course there is a drawing of the space station itself. So you can see that we left South America, we're over the Atlantic right now, and very soon we will be over Europe. You can also make, with World Map, very precise pass predictions. You can ask the software to tell you when in the coming days you will pass over a specific site. So let's see, I'm gonna pick a place in northern Italy, that's where I'm from, and I want to know when I will pass over northern Italy. You see, it's in about 10 minutes, and the pass will last for about 10 minutes. It's almost a zenith pass. It's 82 degrees elevation, so we will almost be from Earth, we will be visible almost zenith in the sky. And I say that we will be visible because World Map also tells you where the terminator is, where is the line between day and night. And so you can tell that it's right about there over northern Italy. It means that when we will get there, on the ground it will be night. The sun will have set already. But up here on the space station, for about 10 more minutes, we will be illuminated by the sun. We will be bright. And so on the ground it will be night. You will be easily able to see us, a bright object moving in the sky. For us, of course, those passes are not good to take pictures because we are illuminated by the sun. On the ground it's dark. We only see black. We don't see anything. What World Map can do also is to show you a view of how things will look from your window. You can select, for example, let's say the view out of the window, and let's select the cupola, which is typically where we take pictures from. And this is how things will look from the cupola, from the forward window and the zenith window. Of course, now it's kind of boring because we're over the Atlantic, so you only see water everywhere. It even shows you where our Soyuz is. This is an MWA, a maintenance work area. We have two of those. There is this one on the starboard wall of Note 2, and then there is one on the opposite wall over there. We use MWAs typically to do complex science or maintenance work where it's lengthy, it's complex. We want a nice work environment. We want to be able to secure this equipment. We want nothing to be floating away. This is the stowed position of the MWA. It's tucked against the wall, so it's out of the way. If we have to work on it, probably we want to deploy it to raise it up to a more comfortable angle. You could secure it, for example, here. Most likely you would want to bring it up a little bit, so it's more like a table. And then let's say I have a piece of equipment I want to work on and I want to secure it here. One option is bungees. So I would, first of all, attach rings like this one, where I find them handy, for example, here. And then a second one over there, for example. And then a bungee between the two. And then I could secure, for example, this if I had to do some work on it. We also use this general area to keep stuff that we use all the time. We want it handy. We don't want to have it to put it away all the time. For example, Sharpies, stopwatch, flashlights, Leatherman tool, clips, Velcro tabs. Velcro is very important when stuff floats. So if you find something that doesn't have Velcro, you can quickly put a Velcro tab on it, and then it's easy to attach to a wall or the ceiling or the floor. Brake coat. We also keep a couple of tools actually, like this one with a 5/32 socket, and that's because we use them all the time. This is the type of socket that is used to remove the fasteners that secures the front panels of our racks, and that's because a lot of time there is stowage behind the front panels, and so we need to access the volume behind, or occasionally because we have to do some work on the equipment that's back there. When you're done, of course, you want to restow it. This is one of two identical robotic workstations here on ISS. The other one is in the cupola. This is typically our backup workstation. From a robotic workstation, of course, you can fly the arm, which means that you can operate and control the SSRMS, the big robotic arm that is outside the station. We use it, for example, to capture visiting vehicles that bring us cargo, or to support extravehicular activities, or sometimes even to move a big thing like an entire module of the space station from one location to another. Recently, we used the arm to move PMM. Sometimes we fly it manually, especially for support of extravehicular activities or track and capture. And in this case, we use the hand controllers. This is the translational hand controller. So x-axis, y-axis, z-axis. And this is our rotational hand controller. Pitch, roll, and yaw. Of course, I can move the hand controllers and nothing happens right now because, as you can see here on the control page of the SSRMS, the arm is off. To give us situational awareness of what's going on outside, we have cameras, and we can route several cameras that are outside of the space station, mainly on the truss, to any one of these three monitors. Of course, now they're off. And to do camera routing, zooming in, zooming out, panning, tilting, we use this control panel. It also contains a lot of controls for the arm itself. For example, very important, the safing switch. If something is happening that is not supposed to, you can safe the arm and everything stops. This is Civis, our Cyclo Ergometer. I'm sure it doesn't quite look like a bike to you yet, but I will show you that you can actually bike on it. I also want to show you first, though, that it's mounted on a movable frame that is attached to the space station via an isolating system, a dampening system, so that we impart as little as possible of the loads we generate on the bike into the structure of the ISS, and that way we protect the microgravity environment of the space station. So let's say I want to do a Civis session now. The first thing would be to flip on the switch so that the Civis computer has time to boot up while I get ready. I've done that already. And then I would move the actual bike, space bike, out of its stowage position, here out of the way, into its working position. So just fold it out and lock it in place. I would put bike shoes on. I already have them for today, but they would be stored in this mesh bag. And then I can jump on the bike. I clip my shoes in. I can use the strap to help me stay in place. although you do also need to hold on with your hands. And then I rotate the series control panel in a comfortable position for me. I select my protocol, and then I'm ready to bike. This is the airlock, or actually one of 3 airlocks on the space station. There is an airlock in the Russian segment used for Russian spacewalks or EVAs, and then there is a small airlock in the Japanese laboratory, which is only used for things, not for people. This is the airlock from which we do spacewalks or EVAs in the NASA suit, which is the EMU. You can see 2 EMUs here, which are ready on the donning station. This is where spacewalkers would put them on. This larger volume is called equipment lock, and all of the pre-EVA, post-EVA operations happen here. Also a lot of work leading up to an EVA, maintenance work on the suits, everything happens in this volume, the equipment lock. You see a smaller volume over there, that is the crew lock. And of course that can be separated from the equipment lock by its dedicated hatch. And that's what we would do on the day of a spacewalk, when everything's ready after about 6 hours of pre-EVA activities. The suits with the spacewalkers inside would be put in the crew lock, the hatch would be closed, and then only that smaller part over there would be depressured. Some of our meals up here are in rehydrated form. You have to add water before you can eat them. Others are pretty much ready to eat. You just need to warm them up. That's the case of thermostabilized pouches like this one. This is one of my favorite meals, a quinoa salad with mackerel and dried tomatoes. And all you need to do is to put this pouch in the food warmer. This is our food warmer. So you open it up, it has 2 sides. You pick a side, put it in, close it, and then you turn it on. It was already on in this case. This red light tells you that it's on, that it's actually warming. And then there is 4 green lights. The first one tells you that it's been warming for 10 minutes, 20, 30, 40. At 40 minutes it will automatically turn itself off. It's pretty easy. This is part of the emergency equipment of the space station, in particular for the case of a fire. These are called CSA-CPs. We have 2 of them here, as you can see, and 2 more are down in the service module. And the purpose of the CSA-CP is to measure the concentration of combustion products in the atmosphere, in the air. This is PMA-1, the Pressurized Mating Adapter number 1. It was launched together with Node 1, and it is the transition element to the Russian part of the space station. Down there you can maybe catch a glimpse of FGB, which is the very first module of the space station that was launched. Today we used PMA a lot for stowage. We keep in here a lot of pantry items in their own dedicated bags or CTBs. For example, here you can see the disinfectant wipes pantry. Pantry means that those items are not tracked individually. This wipes bag doesn't have an individual barcode, and so I am free to come and grab any disinfectant wipes bag from the pantry when I need one. That of course doesn't mean that I am free to come and grab, for example, a clean washcloth every time I want one. There is an expected usage rate. For washcloths, for example, is 1 per week per crew member. Other pantry items include trash bags. There are different types. These small green ones are used for wet trash, mainly used food packages. And then we have our big trash bags that are used for dry trash. And for some reason, in this locker in Node 1 deck, we keep the ISS toolbox, the main toolbox. So we have tools in other locations as well. There are spares in Node 2, Columbus has its own little toolbox, and there are many special purpose tools that are kept in many different bags in many different locations. However, in this toolbox we keep our daily use tools, the one we use on a daily basis to do our science work or our maintenance work. The toolbox is organized in 5 drawers that can slide out like this and rotate. This is drawer number 1, which contains mainly combination wrenches. And I'm not going to show you all, but I want to show you drawer number 2, which is the one that we go into the most, and it's also the most colorful. It contains our torque wrenches, torque drivers, driver handles, ratchet wrenches, extensions, and this is PMA 1.
Now, for half a year, there is a European visitor, which is the automated transfer vehicle, and this is connected on the back side of the space station. So this is the ATV number 3. And it brings a lot of cargo, but also water, for example, air, oxygen that is pumped to the space station. So it provides the space station with a lot of consumables, cargo, air, water, but also fuel. Behind here is the engine part. So this is pressurized, and behind this wall is the unpressurized section of ATV. And there, for example, we have the fuel tanks, because the fuel, which is also part of the transporter, but the fuel is used for boosting. So we have Progress, the Russian cargo ship, for fueling the engines of the space station and for boosting. But ATV has a great position to put the space station in a higher orbit, because we lose a bit of altitude every time. So here we are stowing it now with things we don't need anymore, be it foam be it trash, and be it old pieces of equipment. And when it's full, after half a year, it disappears.